and other people watching will be so confused.
Cool.
They can't even go to extra help.
What? Still what?
Alright.
3 question mark.
What does that mean?
I mean, yeah. Dude,
I was able to do some of it.
okay.
Like 5 of it.
4.
There was like the last couple questions I was.
The last
sure.
41 through
It
45
went from
was
like, I don't know, to
That's
what?
Yeah, 41 to 55. I was like,
To what?
Nope,
Yeah.
well, I kind of have 4
The
papers
other
due,
ones
so.
were
4 papers.
Yeah, like
Buzz
if
down.
you include
Dude, that's
like
what I'm
summer
stuck
school
in my
applications.
head.
It's like 500
You're doing
words.
summer
Hey,
school.
buzz
What?
down.
You're gonna do summer
Big, I want to
school?
see you bust down. Are you staying on spring? Spain?
Have to. No college.
Or aren't you in Spain next spring?
Okay, so
Staying
let's
on it,
let's get to it.
right? I'm on.
Um,
Yeah.
So which one should we start with? Where should we start?
41. Thank you very
41?
much.
If you're 15, do we just go 4 over and 6 up?
Yeah, if it's just looking for component form, you're 6 to the right and 4 up, right?
Yep.
So the component form would
It
be.
should be 4.
4, 6.
Want to do the other way around?
Did it
Yep.
ask for
4, 6.
components?
It's
No.
4-6.
Yeah,
You're
4 to
going
the
over
right.
4.
Oh yeah, thank you. Sorry, yeah.
Yeah.
Yeah. That's like that. 41?
Yeah.
Let's do it.
Wait, and when you're adding them,
Yeah.
what do you do?
You're just adding the components.
You're just adding the numbers.
The x component and the y component together. So let's take a look at 41. 41 was asking us to do what? Find the magnitude and direction maybe? No, we're not there yet.
Okay. Yeah, we are.
Is that what it was?
Hold on,
Magnitude
Charlie.
and direction?
Like, I think 47 or something is like that, but 41 is like,
41 says
you want to use it
find a
to.
unit vector in the direction of the given vector.
Got it.
Find
We
that.
didn't get to that point. So let's finish the lesson.
Uh-oh.
What did you do? You're not allowed to ever move.
No, it's
Oh yeah, I didn't get 32.
30.
Oh, now it's the wrong way.
Why are you taking the video?
For Sean and Tommy. Okay.
they have
Nah,
it.
screw you. 30 quickly
Yeah, well,
Yeah,
yeah,
let's
when
do
they're
30.
dying of frostbite.
I try to
Let's
make
do
it
30,
That
then
was
I'll
stupid.
finish out the lesson, and then we'll go back to that homework, and maybe there will be a little bit more clarity there. I'm sorry, I thought we had.
What's up with Twitter? 'Cause I wasn't sure if
Yeah,
you
we'll
did. There
clean-
was, like, equation.
We'll clean it up. So this one is just look at a visual representation, right? Right? So if this is V
It's gone.
and this is U, right? And we want to look at subtracting half of U, right? What I'm going to do is I'm going to just draw half of U right there, right? And then U goes in that direction, so negative U goes in this direction. So I'll move it to here, right? I can put the little arrow on back, and then that's the resultant, right? From the start of the first one to the end of the second one.
Got it.
Yeah.
Okay.
Okay. And that's called. We didn't talk about the word for that. That's called a resultant vector. When you add 2 vectors together, the answer is a resultant.
Result.
Yeah. Okay, so let's talk about unit vectors. The unit vectors. We're gonna go back to it. Okay. So a unit vector looks scarier than it is.
It is scary.
Alright, looks scarier than it is. Basically, we're going to take the vector in its component form and divide each component by the length of the vector, the magnitude of the vector. So, write this down, but then we'll show it in practice, and it won't be so bad.
Can you repeat that?
Yep. A unit vector, you're going to take each component of the vector and divide each component by the length of the vector or the magnitude of the vector.
Is that what that line?
That's what that double line means. That means magnitude. So, length.
Wait, what? Wait, what?
What's the difference between
Wait,
like the vector and your...
why do you see the magnitude in 1 then?
Wait, is the magnitude just like the diagram?
What?
Yeah.
Oh, I
Yeah,
see.
let's do it in practice. I think you'll understand it. when we do it.
In the. Okay, yeah, we just.
Yeah, let's just do one.
We.
It's okay.
I'm upset.
You're upset.
Be present.
We're waiting for you? Yeah.
Yes.
Alright, she just I'm surprised. It's February 1st.
Yeah, why don't you just write the information and then put the date on?
It's all,
Yeah.
it's all interconnected.
Do it real quick. Done.
Okay.
Like, oh, yeah.
Okay. So, say we want to find a unit vector in the direction of 2, 5, right? So, first let's take a look at what 2, 5 looks like. Right? Vector -2, 5, sorry.
Well, that's
This is
cool.
vector
You
V.
just drag your graph.
Yeah, kind of nice. So, let's say we go back to 5. That there is the vector V. Okay. Now, what I want to do is I want to find a vector of length 1, right? This vector clearly doesn't have a length of 1, right? And then what a unit vector is used for in math, science, physics, is basically just to give a direction, right? And you know it's a 1 unit length long, and so it just tells you the direction. So what we're going to do is we're going to find the magnitude of V. How do I find that?
Oh, you use the distance formula.
Yeah. So that's going to be
Just
-2 squared plus 5 squared, right? So 4 plus 9, so the unit vector is equal to square root of 13. Oh no, that's sorry, whoops. Whoops. I did that wrong. So
Equals
it's,
3, right?
Yeah.
what's that?
No.
No, so it's
That's
4.
Horrible. Whoa.
It's 4 plus 25, square root of 29.
First grade math.
Square root of 29.
Who's that? Who's that grade? I don't know.
What's that?
No, it's not. No, it's not.
First grade is like 5 plus 5.
Oh, I could do 25.
Square root of 29. So, so the unit vector, right? We'll call it U. Its components are just going to be -2 over root 29. You know, we could rationalize it if we want. I'm fine with leaving it like this for right now.
Sweet.
Right? And if we looked at the magnitude of this one, right, to prove that it's a unit vector, we could just say magnitude of U equals, the square root of -2 over root 29.
Wait, how'd you get the U for?
Yeah.
What's that?
How'd you get U?
U is just, it stands for unit vector, right? Right? Plus,
Why would you do that again?
why would we do this?
Like, how did you get -2 over root 29? Why did you do that?
What's that?
Oh.
I'm showing you right now that by dividing by the magnitude of the vector each component, we create a vector that's 1 unit length long, right? Because this becomes the square root of 4 over 29 plus 25 over 29, right?
Oh, it's 29.
Right, so the unit vector is length 1, right? And the reason we're using unit vectors is just to show the magnitude and direction, right? So square root of 29 is like, what? 5.5, right? Basically, we're creating a vector that is like this, kind of. That's our unit vector right there. This would be U. And this would be V. Okay?
Wait, so what was the point of that?
The point was just to create what's called a unit vector. A unit vector is just something that gives us information about the direction of the vector but not the length, right? So if you just want to, the idea is if you wanted to take some magnitude and multiply it by a direction, then you could create a new vector. Okay. So we took the original vector, figure out its length, divided each component by the length. This is what we were solving for here. This is the proof that its magnitude is 1 now.
Oh, so if you put those in there.
Yeah.
Oh, so the second step is.
The second part is just proving that the first part was true. Okay?
That is the unit vector.
That is the unit
The
vector
second
here.
part is that.
The second part is just showing that it is exactly 1 unit long.
Oh, because you
That's
have.
okay, yeah.
Also, if you have a coordinate plane of 2 unit long, that'll be 2.
What's that?
No, it will always be 1.
The unit vector.
It
Yeah,
will
by definition, unit 1. Yeah, 1 unit. Okay,
Nice.
nice. Okay, now we're gonna talk about 2 specific unit vectors that are used very
Holy
frequently.
guacamole.
What is this? Ooh, chill. Okay. The horizontal unit vector, right, is just 1, 0, 1 unit in the direction to the right. The vertical unit vector is 1 unit up, right? This I and j, these are what they're called, right? The horizontal unit vector is I, the vertical unit vector is j, right?
Horizontal.
Vertical is what?
The vertical is j, right? And this is like a widely used practice. And what it allows us to do, right? Allows us to do is write the vector in a different type of form that's used pretty regularly, right? So
Wait, so
I is the x direction unit vector, positive x, and j is the positive y unit vector. Okay?
Why is that I and that is y 1 minus j
Where?
in the graph? Oh no, that's yeah. Sorry.
It's okay. No worries.
Because
Wait,
it's
when-
vertical and it looked like 1 minus j there for a second.
When finding the unit vector, why did you put v over the whatever like
The magnitude?
the yeah? Because isn't that how you find it?
That's how we found it. Yeah.
These vectors can be used to.
Are you talking about the last problem
yeah,
or
like the
here?
last thing you just did.
The last problem.
Yeah.
no.
Oh right, yeah.
Come on.
True.
Right? That is all we did. We found the magnitude of the vector,
Yeah.
divided the x component by the magnitude,
Oh,
and
okay,
y
yeah,
component by
yeah.
the magnitude.
Okay.
Yep. Right.
Great.
And so, basically, you got this unit vector in the x direction, unit vector in the y direction. That shows direction in the x direction. That shows direction in the y direction. And it just gives us a new way to write vectors. You can start with a vector in component form, right? And you can multiply the x component by the unit vector and the y component by the unit vector. And the big takeaway is that this can be rewritten in those terms, right? The x component times I, the unit vector I, plus the y component times the unit vector j. Yeah.
Why do we want to use this
What's that?
again?
It's honestly, it's just a different way of expressing vectors.
Is this some of the derivatives from like when mathematicians do like their work and they found this way is
Yeah. this-
easier for them to understand, so they just put it in.
Yeah, and basically so basically I'm just showing you 2 different notations of doing the same thing, right? Because you will see these 2 different notations,
Wait, so V equals.
right? And so it's simpler than it sounds, and when we do it in practice, you'll see, right?
What is the V1, V2?
V1, V2 is like, say you had a vector, right? V1 would be the x component of the vector, V2 would be the y component of the vector, right? And so it could be rewritten as an addition of 2 vectors, right? The x component times the x unit vector, so that gives you the magnitude times the 1 unit length in the x direction, plus the magnitude plus the 1 unit length in the y direction. So it's just it's saying you can break the components into adding the x direction vector and the y direction vector together, which is how we found components in the first place. It's mostly just new notation. There's no major new concepts involved. Okay?
So when it's just like v equals I, u equals j, it's basically like saying v equals like 0, 1, no, 1, 0, and u equals 0, 1.
Right? And so, like, as an example from the last one, right, if I wanted to rewrite this in unit vector form, all it would be, right,
Just negative 2i.
v also equals negative 2i. And often you'll see the I and the J here with little hats on them.
Wait, how's?
Yeah. It's
What?
called I hat, J hat. And it's just a notation that's used for the unit vectors. Serious.
Really?
Yeah.
I don't think so.
Yeah, I just, I'm trying to make sure you guys look cool in college mostly. And hanging out
Really?
with a bunch of nerds that I'm
Not.
pretty sure you'll be hanging out with.
I would just write I and j equally instead of like writing this.
Okay?
What's the point of having a hat though?
The hat
Yeah.
keeps his head warm.
Okay, so you're just kidding.
No, it's real.
Oh,
It's
okay.
used. It's used for real. It just denotes the vector. In this book, they're just going to use it as bold, but you'll see it as a hat in other books. A hat, J hat. It's all good. All right. So if we have an initial point, terminal point, how can we write this vector as a combination of I and J?
Wow.
2
2i
minus, 2i minus negative 1i.
Will be negative
Two
1 minus 2,
2i.
right?
Okay,
Terminal
terminal
minus
minus
3
initial.
plus 5j.
So I'd have negative 3i, right?
Oh, so you can put that in.
Right?
I see you.
Right? So u, the vector u, which is a little confusing because we just use that as a unit vector, but that's okay. Right? 3i plus what?
It's 8.
8j. Right? Simple as that.
8.
It's just a different way of writing it. Right? So we got one way using component form, one way using unit vector form. Right?
I see.
Right?
I see what's happening here.
But wait. How do you change from this to
Wait, how do you
original? Is
What's
this
that?
like a-
Oh, just because.
It's 3 minus 5 would give us the 8.
Oh, 3 minus 1.
Yeah. Right? You start at the terminal point and subtract, and that gives you the direction.
Is this just like a single trip ticket?
So what do you mean?
Like you can change that from here to here, but you cannot change back.
Change back to that? Yeah,
both.
we can't. Yeah, we can't change back to finding the points, right? Because a vector can float around anywhere. It's just a length and direction.
Yeah.
Yep. Okay. So, basically what we did was we took the unit vector u, or the unit vector I, right, which is just, we started 2, so that's the unit vector, multiplied it by negative 3 to get us out to here, right? And we added it to the unit vector j, and multiplied it by 8 to get to there. And then when we add those two vectors together, we get the original vector we're looking at. All right, just a different way of writing it. Okay. All right. So, in the same way we can do, and this form might make some of this stuff a little more straightforward, maybe not, right? If I have u and j and I want to find 2u minus 3v, oh, u and v, I want to find 2u minus 3v, 2u equals negative 6i plus 16j, 3v equals 6i minus 3j. Alright, so 2u minus 3v is just going to equal this minus that, combined like terms. Right? Alright, so I got negative 6i plus 16j minus 6i plus 3j. I just did that distribution right there, right, to get that to be a positive. Right, negative, negative.
Which,
Oh.
what you do,
Oh,
just
never mind.
basically multiply it and minus.
Yeah, that's it. Right? Now we got plus 19j.
Interesting.
Different attack to the same thing.
Wait, why did you change the negative to positive?
Ah, because I'm subtracting the whole thing. Really, this is, I can rewrite this as,
Oh.
right?
19j. Now it makes more sense.
A little more sense.
Yeah.
A little more sense. Okay. Neat. Oh. Now, direction angles, right? If you have a vector either in component form or in the unit vector form that we have, we can find what angle it makes on the unit circle in its direction, right? And if we look at a point, right, an x component and a y component of this vector here, right, on the unit circle, this would just be sine theta, the y point, and the x point would be cosine theta, right? So if I wanted to take now the tangent of theta would be sine over cosine, right? Or we could say the tangent of theta is the y component divided by the x component. In this case, we got b over a, but that's because we're using a vector ai bj, right? So all we can say is tangent of theta equals that, and so we can figure out direction fairly easily, right? Find the direction of each vector, right? So it's as simple as this. We know that the tangent of the angle that this vector forms is equal to 3 over 3, right?
So it's just tan.
So tangent of theta equals 1, right?
Oh, because I and j are basically just like times 1.
They're basically components, yeah, exactly.
And just showing you the, like the coordinates.
Mhm.
So,
Yeah, so theta could either equal, on the unit circle, it could equal
interesting.
root 2 over 2, not root 2 over 2. Theta equals
45.
45 degrees, thanks. Or, where else is tangent of theta equal 1?
I know.
225, right? But we gotta look at context in this type of problem. Which one of these is not correct for this specific vector?
45. I mean 225 is 9.
225, right? Because
It's negative.
the angle would be the same, but 225 would give the negative vector, right?
Wait,
Because you're going in the positive x direction and positive y direction, so we're going up into that first quadrant.
Use any other like, oh yeah.
So we have singular answers. I like it.
Right. Yeah.
Instead of like
Right. And then this one, right? We got tangent
Why
of
do we
the.
use tan though?
What's that?
Because
We use tangent because the y component will be the sine if we're looking on a unit circle.
Oh, because sine thing.
Yep, and x is cosine, so it's sine over cosine tangent.
y over
Right? So now we can say tangent of theta equals
negative 4 over 3,
negative 4 over 3
which is
inverse tangent of negative 4 over 3 is going to be the angle. We could find it, right? What is it?
Wait, is that negative 4 over 3 like the continuum of the A equation or B?
B.
B.
4 over 3.
Error.
Right, go.
Yeah.
Yeah, and your calculator, you're going to use that as the minus sign.
Wait, why do you have to
Oh.
do that?
Oh no.
What's that?
You use this.
Oh, you have.
Oh, negative 4.
Negative,
Yeah.
yeah.
Oh,
Right.
when you use X, it's only so.
Yeah. Yeah, 4 over 3 is not on the unit circle, so I'm just leaving it like that.
Negative 53 degrees,
So it's negative 53 degrees.
which you plus 360, right?
Not plus 360, it's tangent, so it'd be plus
oh,
180.
Oh, yeah, right. Sorry.
Alright?
Yep.
Alright?
Bang. 126.870.
So I'll do 127.
Yep.
Right? right?
Sure.
Which one of these is correct?
Negative 53.
Yeah, right, it's gonna be pointing into that fourth quadrant,
Yeah.
right? I could represent that as negative 53, or I could call it, what's 360 minus 53?
360 minus 50.
307.
Wait, really?
Why?
Oh yeah, right.
It's the same angle,
It's what do you call that?
Oh,
again?
yeah.
right? It's a coterminal angle.
Yeah.
Yeah, those are coterminal angles. Okay, does that part kind of make sense? Okay.
Could you leave it as negative 53?
Sure, yeah, sure. Unless I was asking for an angle between 0 and 360,
Okay.
right?
Oh, you limit the range. Of
Yeah, right?
Uh,
Okay, so now let's go back to the homework.
okay.
Now,
No, actually, I think you don't need to explain the homework now. For me, at least.
Okay. Good for you.
Wait, do you
Okay,
know?
Jason.
I don't know.
Yeah,
I don't remember it.
that's all right.
The
So
Let the
let's
questions out.
let's
Yeah,
think
so
about
how
what the
would I know
questions
if
are
I
asking.
knew
Do I have a
the-
book in here?
Did you do it?
Hold on, let me get a book and then I can
Okay.
look along quickly.
Okay.
I'm so hungry.
See,
It's already 11.
What
dude,
time is it?
having G free today is clutch. I don't have to get here until 9:40.
Well-
I sleep until like 8:45.
Having G3
My sister's
doesn't
G3
work
too.
for me and for you.
Why?
Because we have to wake up at 7:30
We
to
didn't have to
do,
do that.
To do what?
to fill out that form.
What did you sign up for?
I didn't know
Mount
this.
Washington,
Bro, I did too.
finance,
Mount Washington?
business,
Yeah, even though Dan told me
hunting,
but I
safety,
You signed up for Mount Washington.
wilderness,
Yeah.
survival. Well, I don't know what
Yeah, we did that
happened to
in backcountry
tennis.
skiing.
People filled that serving up to Cape Cod thing.
I have a feeling
No,
that
that's
it's
so,
because Ted
that girl
isn't
who
here
got cleared
anymore.
after 4 months is
Really?
the stupidest thing.
Yeah.
Yeah.
Tennis
That's
isn't
the
what?
like
Ted
no surgeon
doesn't
ever.
work here anymore.
Who are you using as your
Tennis is
Dr.
what?
Coker,
Ted.
Boston Children.
Maston used to run that trip and he doesn't work here anymore.
Oh, wait.
Hotel.
Really?
Rip.
Yeah.
But Brooke is,
Yeah, Brookie.
and everybody likes Brooks. I mean Brooke.
The
Which one?
backcountry trip seems sick.
The serving up to Cape Cod thing.
Where are you going? Like Stowe area?
Yeah, we're gonna be in Mad River Valley. We'll go
Yeah.
Stowe, and there's some good trails in Randolph. They have like a good network cut out. Brandon Gap.
Should go up to Tuckerman's.
Yeah, we probably won't that time.
Yeah.
It'll be a long travel. There's some more accessible stuff that's around
That's
in Vermont. Yeah, it'll be super fun.
Wait, who are you doing it with?
Josh.
That's so sick.
Oh, where are you going?
How many kids are you taking?
I think 8 or 10, something like that.
That's sick.
Wait. Oh, are you going to ski?
That'd be so sick.
What's that? Yeah, skiing. This one just said find the unit vector, right?
Yeah, so then you can just put it into.
I can do square root
Yeah.
of -2.
See.
Okay, Jason.
Cool.
Right? So the unit vector would be then,
Oh. My.
Wait.
Oh.
right?
Oh yeah.
And if I wanted to rationalize this, this would be negative √2 over 2 and √2 over 2 would be the unit vector.
Wait, how did
How'd you get that?
So this would be the same as negative 1 over √2 and
Oh, yeah.
1 over √2, and then I would just rationalize it, √2 over
Oh, yeah,
2.
wait.
I just multiply the top and bottom by √2.
So that's the answer.
Yep,
Wait.
So
So
what?
that's just your answer.
that's the answer. It was just asking for, this one was just asking for what is the unit vector. That is the unit vector.
√2 over 2.
Yep, √2 over 2.
Huh?
Yeah, exactly. Yeah, that's the unit vector in component form,
Oops.
right? We want to write it in unit vector form, it would just be negative √2 over 2i
Isn't
plus √2 over
That's all
2j.
the units.
Isn't this just supposed to be 1?
Yeah.
Like tangent equals 1 for, because, no, not tangent equals 1. Yeah. No. Sorry.
It's alright, man.
It just said.
It's alright.
Never mind, yeah.
That's okay.
Is lunch after this?
Yes.
I'm so hungry.
We should talk about this while on our way to Jake's.
Jake,
Jake's.
you already paid for the dining hall. Alright,
Jason.
this question was asking, what else do we want to look at now?
It's 6 more minutes. I can't believe-
51.
6
Yeah.
more minutes until what?
lunch starts.
Oh, until lunch starts, not until this class ends.
Shit, he tried to bamboozle you, Chris is not.
Not a
Not a
chance.
chance. No bamboozle.
This is the same problem as the last one.
51?
47 is the same as the last one.
Oh,
You
yeah.
want to do 51?
Yeah.
You
Okay.
just do it. Oh, for W thing, do you just change it to the
Oh, this is saying,
never mind.
Wait, what? 42nd.
what's that?
Wait,
Yeah.
47, Chris?
What?
Do you just change it to
You don't have to change the component form. You can just divide the
How
I
about
part by
51?
the magnitude and the j part by the magnitude. It's fine.
but you have to know
Yeah, you gotta find it.
so you still have to
Still
change
have
it
to
back.
do the distance formula thing.
Yeah, but yeah, so you have to change back to the coordinates. Okay. Thank you.
Alright, so this is 51. 51 is asking us to find the vector with a given magnitude in the direction of u. Okay? Wonderful. So,
What was that?
we want to find a vector
Okay.
that is in the same direction as this,
Yes.
but that length, right? Right now, the length of this vector is the square root of 29. We did a similar one like this already, right? But I want it to be length of 9. So this is what I do. I take this vector, all right? I know the magnitude of u is root 29, right?
Wait. Oh, yeah, because
Yeah,
you already
2
had-
squared,
yeah,
5
yeah,
squared.
yeah.
We just did one like this.
Oh, and you 9.
We want a vector in this direction of that length, right? So what I can do is I can find the unit vector here, right? This is,
Don't you just need 9 divided by that thing?
oh,
Oh, and then just multiply them.
and then just
and
multiply
then
by
square
9.
it and multiply it
Wait,
by.
you just know that it's 29.
I need to square.
Yeah, we just did one like
So we
this, where
squared
2
off.
squared and 5 squared, right? So this is the unit vector, right? And so that's the unit vector.
Also, is that fine if you have it on the bottom?
Yeah, for right now, let's just worry about the concepts instead of the rationalization. That's a different kind of whatever, right? So if that's the unit vector, and I want to multiply the unit vector by a magnitude of 9, all I gotta do is 9 times the unit vector.
Whoa. Okay.
Yeah.
And our new vector,
18.
What she was doing.
So that's V.
yeah, that's V. This is V. This is vector
Okay,
V.
this is V.
Yeah, and then 45
Wait, plus something.
over root 29.
And you're good.
Couple weeks ago.
Yep.
Wait, you want to find the unit factor that of the length of 9?
No,
After she had
we want to
this
find a
thing,
unit
she
vector.
was
No, we want a vector in this direction with that magnitude. So if I find the unit vector, right, that'll give me that direction still, but of magnitude 1. And then if I take the unit vector and multiply it by 9, I know it has a magnitude of 9 now.
I see what you're doing.
Yeah. Sneaky.
Shady.
Mm-hmm.
Slim shady.
Does that feel all right for everybody?
Yeah.
Cool. All right. What else do we have for
Is
homework?
this an hour more?
Yeah.
Can we do 55?
Yep. We can do 55. 55 was asking for,
No, they don't. No, they don't.
here's the initial points and terminal points. Right, so this one's easy now, right? That's the initial point, that's the terminal point.
Yep.
And it just wants it in terms of a combination of vectors I and j. It's just what we were doing before.
Oh, so
So it's
just like-
0 minus negative 6,
6, negative 3. So
j,
6,
oh I, sorry.
6i, negative 3j.
Yeah. Come on.
Oh, you just subtract them?
Plus 1 minus 4 j. So it's 6i. 1 minus 4 is negative 3 minus 3j. That's it for that problem.
That's it.
That's it for that problem.
Oh,
Okay.
that's a lot easier.
Yeah. A lot easier than what you thought. We just didn't have the time to get to everything, but that was kind of the plan. Okay, so now let's try a couple of things in practice. I mean, word problems. Come on, come on.
Lindsay won.
Oh gosh.
She was gonna quit.
Cause her knee was so bad.
Yeah,
She had, like,
after
nerve
she
damage.
extended her knee, she lost feeling in her feet.
She was itchy.
Yeah, nerve damage from some of the surgeries and stuff.
All right.
What are we trying to find here?
I want to find the velocity vector and component form of this airplane.
Velocity vector, which is just
In
like
component
unit
form.
vector.
What's that?
Which is unit vector.
Not the unit vector. Just the component form. I want to know, what is this component? And what is this component?
50
Right.
and
50.
Well, you can't assume that. Well, we know this length is 150 and we know the angles. So we're good,
Yeah, you have the
Right.
the V.
oh right.
Oh, gotcha.
Yeah.
right? And this is as simple as this. The x component of a vector is just equal to the magnitude of the vector, 150, times the cosine of the angle. And the angle I'm using is this angle, like a unit circle angle, right? So if we're 20 degrees below the horizontal, add that to 180 and I get 200, right?
Is there a
200 from the starting point, positive x direction.
Is there a number for this problem?
Wait.
Oh, I found it.
Ooh, you got it? Cool. Yeah, it's on the the
20
chapter. Yeah.
This
Couldn't you
was
just do
cost
70?
money.
What's that? Now, the reason why it's good to be consistent about the angle we use starting from the positive x direction is that this will give me the right sign always, right? Cosine of 200 is negative. Sine of 200 is negative. So it'll give me a vector that's negative in the x direction and negative in the y direction. Alright, so this is just going to be 150 cosine 200, 150 sine 200.
Wait,
Right?
Oh, because that's
Can you
X
explain
and
that
Y.
again?
Exactly.
Okay.
Yeah. What's that?
can you explain that again?
Explain which piece. Why we use the 200. We're using the 200 instead of just creating a small right triangle because in the right triangle we'd come up with all positive values for x and y, right? But we're talking about this is positive, that's negative, that's negative. The 200 will allow us to have a negative value for the x and a negative value for the y. Somebody want to do that robot work on the calculator?
Jason's got it.
Yeah.
Right.
Like always.
Like always.
Negative 149
Negative 140?
for the first, the x. Sine 200. Negative 51 for the y.
Perfect.
Okay.
So it's negative 51, it's not 50.
And then we'll call this V, velocity vector, often it's called V. So this is a pretty straightforward one. But that's it. That's all I was asking us to do on this problem.
I feel like the hard part is to know what to do.
It's okay. We're gonna do a couple more. So if I wanted to write this in unit vector form, what would that look like?
Take the square root.
Nope, just as simple as
What do you mean?
Oh.
Oh, you mean change
Yeah.
from that to UK?
yeah, totally good.
Ooh, agile.
Oh, don't unplug it though. Right, so that one's pretty straightforward.
Yeah.
The next one is a little more complex. Okay. We've got a boat, pulling the boat out of the water, right? We know how much it takes to pull the boat out of the water, right?
Little physics here.
A little physics, right? We want to know how heavy this thing is, right? So we're using, our vectors that we're using are force vectors, right? Force can be measured in pounds. Your weight is a force, right? Because you weigh different things in different places.
The weight is a force.
Yeah,
Yeah,
weight,
because it's-
weight is a
you're
force
getting
measurement.
pulled to the earth,
Right.
So that's the force. And which
Basically, yeah, when you have a
What?
scale, your scale is telling you how much force is being applied to the scale,
Exactly.
right? So your weight is a force. If you put a scale on the moon and weighed yourself, your weight would be less because you'd be applying less. Yeah, you'd be applying less force, right? Mass is not a force.
Oh.
Right? The weight is, right? So we know we're pulling up with some force. Now the first thing I want to do for this problem, and will be helpful in a lot of problems, is to create an x and y axis. This is x, this is y, right? And what that does is it tells us in the direction of motion, we want one of our axes to be the direction of motion, which is what the boat's moving on, and the other one to be the other, right? Now, a little bit of physics. One of Newton's laws, Newton's second law, is that, I don't think I even have much of that on the screen, but it's okay. Newton's second law says force equals mass times acceleration, right? So, there's two ways you can have zero acceleration. One is if something's sitting still, and the other is if it's moving at a constant speed, right? We're going to assume that this is moving at a constant speed. So what that means is the forces in the x direction should all add up to 0. When we add all of the vectors of the forces in the x direction, they should add up to equal 0. And the forces in the y direction should equal 0. That's going to help us figure out the weight of this boat. Okay. So we want to say that we've got two vectors. We've got this vector right here is the weight of the boat that goes straight down, right? And the second vector is this pulling vector. We'll call that P, and we'll call this one W for weight. Okay? Now, we want P plus W to equal 0. Okay? Now, P, and let's do this one in unit vector form, right? What is P in unit vector form?
Aside,
600.
600i, right?
Unit vector?
Yeah, the ij is what I call unit vector form,
Oh.
right? Because you're
unit
adding,
vectors.
you're using those two unit vectors I and j,
okay.
right? There's no j component of the pulling force, correct? No y component of the pulling force. Okay, so that's good. We got that good there. Now, we've got, excellent. So, W, this is a good way to look at it, right? So, x components equals 0. The y components have to equal 0 too, right? So I know that the x component of the weight plus the x component of the pull equals 0. So now what's the x component of the weight?
What are those? Y exponents is 0.
What's that?
Y x components is 0.
Why are they 0?
Yeah.
Because we're going to move at a constant velocity, right? Which means that the sum of the forces equals 0 because the acceleration is 0. That's why.
I think I know.
So what's the x component of the weight?
Wait. What does it weigh? Oh, we want the.
This is 600.
Negative 600, right? Right? The x component of the pull, if I'm looking in this direction, the pull is going 600 pounds that way. The weight's going to be pulling back 600 pounds that way.
Yeah, but
The sum of forces equals mass times acceleration, right?
the weight is pulling it down.
The weight's pulling it back,
Yep.
and you're pulling it forward.
Forward.
And if you're getting it to move, then you have to have at least the same pull force as the weight, or else it won't move, right? If the weight pulling back is more than you're pulling forward, it's gonna stay.
Wait, if they're the same, why would it move?
They're the same. It can move at a constant velocity. But that's the one. That's the amount that you have to get past until it works. So
Oh,
if we find the limit, then we know the weight.
then why don't you just use the pole minus the? I mean, oh, I see what you. Oh,
All right, we're just figuring out what the pulling force has to overcome, right, to actually move it. So this is the x component of the weight. Okay. So far, okay. No.
okay. Actually confused. I guess. Oh, so you're just saying, a perfect situation that when your pole equals your weight.
If your
So
pull
that's-
equals your weight,
that's-
you can get it to move, and it'll
that's
keep moving.
Weight W, which is going that way,
Weight in this direction.
and then pole is like up.
Weight in the
Yeah,
x direction
yep.
is 600. The pull is 600.
Oh, okay.
Right?
Okay.
So now we've got this. Right? What is this? This is
That equals 600. Or negative 600.
right. This is this little triangle that's formed here, right? We got the full weight of the boat
Okay.
and the trailer, right? We've got
The rim.
we've got the x component of that weight and the y component of that weight. So this is wx and this is wy. Right? And we know this. This is 15 degrees, or we could call it this angle here would be, that angle's 15, what's this whole angle?
200.
Oh.
200.
Oh no.
That's 15.
This is 15.
Oh, minus
175.
270 minus 15.
No, 180 plus 75, which is 200 times 55.
Cool. Yeah. Sorry, everyone.
Yeah, you already did that.
Okay.
Wait, it's not 15.
This angle's 15, but if I measured it from the positive x-axis, it'd be 255. What's that?
Do you do that because of the negatives? Or
Yeah, because of the negatives. But in terms of like understanding this problem, Chad, if you have a good diagram and you're more comfortable just using that triangle and you know what's positive and negative, just do that. Okay. So if I know this is negative 600, right? And this is 15 degrees or 225 or whatever we want to call it. Let's just work with the 15 degrees, okay? What we can say is that the total weight, right? The total weight is equal to, no, let's do it like this. Come on. It's okay. We can say that the sine of 15 degrees, right, in this case, using this triangle, equals the x component of the weight over the length of the weight. Does that make sense?
No.
What do you mean length?
The magnitude of the weight, yeah.
Oh, because it's straight down.
Yeah, straight down. The weight is always going to go straight down, right?
Oh.
Towards the center of the earth.
Yeah, but what the magnitude of the weight?
But isn't the magnitude of the weight 600?
Or just one?
The x component of the weight is 600,
Okay.
right? That's this piece of the weight is 600. It's going to weigh a lot more than that, right?
What's the magnitude?
What's that?
Isn't that negative 600?
Negative 600. This one is, yeah, absolutely.
Oh,
Right?
okay, okay, okay.
Since we're just using this little triangle and we're kind of not going with the big angle, I'm just going to call it positive 600 and we'll interpret it correctly at the end, okay? So we can say that 600, which is the weight in the x direction,
Yep.
equals 600 equals
Isn't that pole?
sine 15, right?
Right?
And then 600 sine 15 equals the weight.
Wait, WX is negative 600, isn't it?
Yeah. Yeah, I'm saying because we decided not to use this 255 just in terms of like a conceptual understanding of the problem, we can just call this, we're just calling these all positive lengths right now. Right? It's negative because it's going left,
Yeah.
right? But if we're just using this as an understanding of what's going on, I'm just going to say that this is positive, this is positive, this is positive, and then we'll interpret it at the end.
And we just.
Yeah.
You can just add a negative.
We'll just
sign.
interpret whether it's negative or positive based off of the diagram that we have.
Well, doesn't it have to be positive at the end because it's the weight of the boat and the truck?
Yeah, we're looking for a magnitude, and a magnitude is not giving direction, it's just giving the
Yeah.
size of it anyways. So, 600 times 15.
Jason.
Jason
Wait a
600
minute.
sine 15.
Wait a minute, did I do that wrong?
Yeah, I think it
Yeah, I
should
totally did that wrong.
600 divide.
600 divided by sine 15.
Yeah, I was like confused.
Thanks. I was like, it shouldn't be less.
Wait, how? Oh.
I just did the algebra wrong.
Algebra.
Unbelievable.
I algebra blew it.
Divided by sine
Algebra.
15.
Yeah, so 600 divided by sine 15 equals the weight,
You're right.
and that equals something fairly big.
2,318. Jeez.
Which is reasonable for a trailer and a boat.
Oh, pounds? Wait.
Pounds. So divide that by 2.2 and that'll give you kilograms.
Okay.
I figured that's what you're looking for, right?
1 ton?
What's that?
It's
Yeah,
a
it's
one
over a
ton.
ton, yeah.
Little boat.
It's a boat.
Boat and trailer, yeah, it could happen. For sure,
Yeah.
for sure.
Cars.
Isn't much
and
heavier.
Okay.
Okay.
Well, I think we're probably good for today. I only have one more.
Little boat.
Okay. We're doing this.
Oh, that's a bearing one? Lame.
Gross.
Are we not doing it?
No, we're going to lunch.
Yeah, because we're
Because we're hungry.
Yeah, because.
What's after this?
D and C.
D and then C, yeah.
Because I woke up too early, so I didn't go to breakfast.
Oh, that just fell right at the end here.